Question 1. Which one of following is the strongest oxidizing agent? We have four options over here. The oxidizing power of oxides of chlorine decreases as HOCl, HClO2, HClO3 and HClO4. So HOCl is the strongest oxidizing agent, therefore option A is the correct answer. Question 2. Which of the following inert gases has the highest ionization energy? We're given four options over here. Noble gases have completely filled valency shell. Large amount of energy is required to remove an electron for completely filled valence shell. Hence they have very high values of ionization enthalpies. On moving down the group, the ionization enthalpy decreased from helium to radon due to increase in atomic size. Hence, helium has the highest ionization energy. Therefore, option A is the correct answer. Question 3. The ease of liquefaction of noble gas decreases in the order. We give four options over here. With increase in atomic number, the liquefaction tendency increased from helium to radon due to increase the strength of van der Waals forces. Thus, the ease of liquefaction of noble gases decrease in the order of cerium, krypton, argon, neon, and helium. Therefore, option B is the correct answer. Question 4. The inert gases with the highest heat of vaporization is? We give four options over here. With increase in atomic number, heat of vaporization increase from helium to radon due to increase in the strength of van der Waals forces. Hence, the radon is the inert gas with the highest heat of vaporization. Therefore, option D is the correct answer. Question 5. Choose the correct statement. We are given four statements over here. Chlorine is insoluble in water. B. Iodine is a solid. C. Iodine is more reactive than bromine. D. Bromine is more reactive than the chlorine. Chlorine is slightly soluble in water. The reactivity of halogens is of the order of 2 chlorine, bromine and iodine. Therefore, we see iodine is solid. Therefore, option B is the correct answer. Question 6. Select incorrect statement about the inert gases. We have four options. The ionization enthalpy of each inert gases is the highest in its period. B. Inert gases have a large negative values of electron gain enthalpy. C. The atomic radii of inert gases are larger than those of halogens. D. All of the inert gases are monoatomic in nature. If we see option A, C and D are correct. If we see option B, inert elements have a large positive values of electron gain enthalpy because they have no tendency to accept electron as they have stable electronic configuration. So among this, the incorrect statement is option B, that is inert gases have a large negative value of electron gain enthalpy. Therefore, option B is the correct answer. Question 7. The correct increasing order of the dipole moment of the following is? We give four options over here. Dipole moment depends upon the electronegativity of the atoms in the molecule. Oxygen is the second most electronegative element and the electronegativity decrease on the moving down the group. So the increasing order of the dipole moment will be, if we see option B, that is H2TE, H3SE and dihydrosulfide and H2O. That therefore option B is the correct answer. Question 8. Bleaching action of sulfur dioxide is due to? We give four options over here. SO2 is the presence of moisture act as a bleaching agent. This is due to the reducing nature of SO2. Therefore, SO2 plus of 2H2O gives us H2SO4 plus of 2H. Therefore, colored matter plus H gives us colorless matter. Therefore, option A, that is reduction, is the correct answer. Question 9. In oxygen fluoride molecule, the total number of bond pair and lone pair of electron present respectively are. We give four options over here. Oxygen fluoride molecules can be shown as FOF. Oxygen has two lone pairs while each fluorine atom has three lone pairs each. Hence, there are two bonds pair and eight lone pair of electrons. Therefore, option B, that is 2,8, is the correct answer. Question in gradual addition of electronic shell and the noble gases causes a decrease in their. We're given four options over here. As the number of shell increases, size increases, and the effective nuclear charge on the outermost electron most decreases. Therefore, ionization energy decreases. Therefore, option A is the correct answer. Question 11. Amongst lithium chloride, rubidium chloride, and beryllium chloride and magnesium chloride, the compounds with the greatest and the least ionic character respectively are. We give four options over here. Rubidium chloride and beryllium chloride. Larger the action, more is the ionic character, or smaller the cation, greater is the covalent character by Fresnel's rule. Therefore, option P, that is rubidium chloride and beryllium chloride, is the correct answer. Question 12. Property of the alkaline earth metals that increases with the atomic number is. We give four options over here. A. Ionization enthalpy, B. Solubility of the hydroxides, C. Solubility of the sulfates, and D. Electronegativity. Solubility of hydroxides of the alkaline earth metals increases down the group since their lattice energy decreases more rapidly than the hydration energy. Therefore, option B, solubility of the hydroxide, is the correct answer. Question 13. Barium burns in air to form. Alkaline earth metals combine directly with oxygen, that is O2, to form oxides which, when further heated in the presence of excess of oxygen, form peroxides. Therefore, option A, that is barium oxide, is the correct answer. Question 14. A certain metal is used to prepare an antiacid which metal accidentally catches fire which cannot be put out by using CO2 based extinguisher. The metal is, we give four options over here. Generally, magnesium hydroxide is used as antiacids. The metal is magnesium which burns in CO2 atmosphere. Therefore, 2 mg plus of CO2 gives us 2 MgO plus of C. Therefore, we see option C, that is magnesium, is the correct answer. Question 15. Barium oxide is least soluble in. We're given four options over here. It is readily dissolves in aqueous solution of barium chloride, like magnesium oxide and magnesium chloride. That is magnesium chloride solution, which is called as Sorel cement. Therefore, barium oxide does not dissolve in a pure water. Therefore, we see option A is the correct answer. Question 16. The reaction of slag lime with chlorine gas gives. Again, four options over here. Calcium hydroxide plus of chlorine gives us calcium, that is bleaching powder, plus of H2O. Bleaching powder is mixed with salt of calcium hypochlorite, which gives us calcium hypochlorite, and basic calcium chloride, that is calcium chloride, calcium hydroxide, and H2O. Therefore, we see option C, the mixture of a calcium hypochlorite and a basic calcium chloride is the correct answer. Question 17. A binary compound formed between the elements with atomic number 19 and 17 is expected to be. We give 4 options over here. Element with atomic number 19 will lose one electron, and element with atomic number 17 will gain that electron to form an ionic water soluble compound. Therefore, option A, that is a water soluble compound forming an conductant solution in water, is the correct answer. Question 18. The order of solubility of lithium halides and nonpolar solvents follows in the order. We give 4 options here. As the size of an anion increases from fluorine ion to iodine ion, the covalent character increases and hence the solubility in nonpolar solvent increases as lithium iodide, lithium bromide, lithium chloride, and lithium fluoride. Which is, we see our answer matches with option A. Therefore, option A is the correct answer. Question 19. The melting point of the chlorides of alkali metals decreases in the order. We give 4 options over here. Lithium chloride being covalent has a lowest melting point. The melting point of the other like decreases from sodium chloride to cesium chloride as the latter's energy decreases. Therefore, option B, that is sodium chloride, potassium chloride, aluminum chloride, cesium chloride, and lithium chloride, is the correct answer. Question 20. If sodium ion is larger than the magnesium ions and sulfur ion is larger than the chlorine ion, which of the following will be the least soluble in water? We give 4 options. Right? Higher the lattice energy, lower the solubility. Out of the 4 combinations possible, the lattice energy of magnesium sulfide, which is bivalent ionic solid, is higher than those of sodium sulfide, magnesium chloride, which they are bivalent or biunivalent ionic solids, and sodium chloride univalent ionic solid, and hence magnesium sulfide is the least soluble. Therefore, option D is the correct answer. Question 21. For a transition metal ion having 7 electrons in its d subshell, the effective magnetic moment will be. So this will be. Question 21. For a transition metal ion having 7 electrons in its d subshells, the effective magnetic moment will be. We give 4 options over here. So if d orbital contains 7 electrons, it has 3 unpaired electrons. So the magnetic moment that is mu equal to n of n plus 2, which is equal to 3 of 3 plus 2. Solving this further, we get 3 into 5, which is equal to 15. Taking a root of 15, we get 3.87 pm, which is option C. Therefore, option C is the correct answer. Question 22. Which of the following forms interstitial compounds? We give 4 options over here. The transition metals such as iron, zinc,, and vanadium form a large number of interstitial compounds in which small atoms like hydrogen, carbon, boron, and nitrogen occupy interstitial sites in the lattice. Therefore, option D, that is all of this, is the correct answer. Question 20. In acidic medium, 1 mole of magnesium oxide accepts how many moles of electrons in a redox process? In acidic medium, the reaction is Mn4 plus of 8H gives us Mn2 plus, and that is plus 4H2O. So oxidation states of manganese changes from plus 7 to plus 2. Acidic medium, that is 1 mole of it accepts 5 mole of electrons. Therefore, option C, 5, is the correct answer. Question 22. Electronic configuration of copper, that is atomic number is given as 29, is, we give four options over here. The expected electronic configuration of copper is argon 3d9 4s2, but actually it is found to be argon 3d10 4s1. This is because fully filled d orbitals are more stable than the incompletely filled d orbital. So there is a migration of one electron from 4s orbital to 3d orbital to give more stable configuration. Therefore, option B is the correct answer. Question 25. Which of the following statement about transition element is incorrect? We give you four options over here. The transition metal ion which have completely filled d orbitals such as zinc, cadmium, mercury, copper, silver and gold ions are colorless. The transition metal which have completely empty d orbital, that is scandium, titanium, etc. are also colorless. Therefore, option B, that is all the ions are colored, is the correct answer. Question 26. Reason of lanthanide contraction is, we give four options. Negligible screening effect of F orbital is B. Decreasing nuclear charge, C. Decreasing nuclear charge and D. Decreasing screening effect. Due to poor shielding of 4f electrons, increased nuclear charge is experienced and the valence shell is pulled slightly towards the nucleus, thereby resulting in the lanthanide contraction. Therefore, option A, negligible screening effect of F orbital, is the correct answer. Question 27. Which is not the correct statement about the chemistry of 3D and 4F series elements? We give four options, that is A. 3D elements show more oxidation state than 4F series elements. B. The energy difference between 3D and 4S orbitals is very little. C. Europium is more stable than cesium. Sorry, it is cerium. B. The paramagnetic character in 3D series elements increase from scandium to copper. Elements having unpaired electrons in their outermost orbit are termed as paramagnetic. In 3D series elements, number of unpaired electrons increase from scandium to manganese and then decrease from iron to zinc. Therefore, paramagnetic character increase from scandium to manganese and then decrease from iron to zinc. Therefore, option D, the paramagnetic character in 3D series elements increase from scandium to copper. Therefore, option D is the correct answer. Question 28. An element in +3 oxidation state has the electronic configuration argon 3d3. Its atomic number is, we give four options. The element in +3 oxidation state has the electronic configuration of argon 3d3. So the electronic configuration in element form argon 3d6. So the atomic number is sum of atomic number of argon and 6 electron in 3d subshells, that is 18 plus of 6 is equal to 24, which is our option A. Therefore, option A is the correct answer. In the context with the transition element, which of the following statement is incorrect? We give four options. In addition to the normal oxidation state, the zero oxidation state is also shown by this element in complexes. B. In the highest oxidation state, the transition metals show basic character and form cationic complexes. C. In the highest oxidation state of the first give transition element, all the 4s and 3d electrons are used for bonding. D. Once the D5 configuration is excited, the tendency to involve all 3d electrons in bonding decreases. The basic character of any element changes with the oxidation state. Low oxidation state are more basic and high oxidation state are more acidic. For example, magnesium oxide and magnesium trioxide are basic, while magnesium is acidic in nature. Therefore, option B, in the highest oxidation state, the transition metals show basic character and form cationic complexes, is the correct answer. Question 13. Knowing that the chemistry of lanthanides is dominated by its +3 oxidation state, which of the following statement is incorrect? We're given 4 options over here. Most of the trivalent lanthanoid compounds except lanthanides with oxidation 3 are colored both in the solid state and in the aqueous solution. The color of these ions can be attributed due to the presence of F electrons. Therefore, option C, that is, lanthanic compounds are generally colorless, is the correct answer.